Yep, let's get back to where we were. Can I get a hello, quickly, just to set the mood?
Hi, bro.
Hi. Yep. Hello.
Hi.
Hello.
Hi. So, okay, enough of hellos. Let's do a quick recap of what we did yesterday. So, can anybody walk me through what we did yesterday? You can leave out the Prisma part. I know we rushed up that part, but I just want somebody to get me the walkthrough of what we did yesterday. It can be very ambiguous. You needn't be really specific to what we did yesterday. Just tell me what and all we did. It doesn't have to be a single person. Just shout out whatever comes to your mind.
We created a database in Heroku.
We created a database with Heroku. Perfect. Yeah. Then
we visualized it in Beekeeper Studio.
We visualized it in Beekeeper Studio. Yeah, perfect. Then we didn't just visualize, we even put data into our database using Beekeeper Studio, right? I mean,
Then we connect backend into the database.
We connected back into the database, correct? Then is that all that we did yesterday? I thought yesterday would have been overwhelming and we covered a lot. So far we had around 3. What are the other things that we talked about? Didn't we talk about the types of databases? I mean, just shout out whatever comes to your mind.
SQL, NoSQL, like what's the difference?
Yeah, we talked about the difference between NoSQL and SQL, right? And what else?
For the HTTP methods that we have.
The HTTP methods that we have. Perfect. Then prismatic ORM. It's not prismatic ORM, it's Prisma ORM. Okay?
Query parameters.
We talked about query parameters. We talked about how and all we can send data to an endpoint, right? Is there anything else?
Middleware.
We started talking about middleware. We didn't get into the crux of middleware. So yeah, middlewares. And then ORM, yeah, we talked about ORM, object relational mapper, how you can convert a relational database and abstract it into an object oriented approach, right? You map it into an object. What else do we see? Maybe if I just open the file, maybe you might get something. What else did we do? What else did we do? I mean, if there's nothing and if you all cannot remember, it's okay, just tell me. We'll skip to the good parts. Okay, cool. I assume that that's all we did yesterday, and even if we haven't really rushed up a bit, it's okay. We'll have a quick recap of what we did yesterday. So everybody hop into my screen. I think everybody's already there on my stream. If you haven't joined, I see 20 and we have almost 27 in the voice chat. So if somebody is yet to join the stream, please do so. Cool. So shall we get started?
Yes.
Cool. So yesterday we talked about creating a web server and we even built our own API, right? We started building our API. We have built one endpoint that would get us the list of cars, its make, its model, its year of manufacturing, and we built another endpoint that would do something with the database, but we haven't really gotten into it. We didn't really talk about it since we didn't have time. Okay, so now what we'll do is I'll just give you a quick recap of what I did yesterday, and since I could not explain about the entire Prisma process, I'm gonna do a quick recap, right? So does anybody remember what Prisma does? You know, what is Prisma? Does anybody remember?
Columns into objects.
It converts rows and columns into objects. It maps. It's an ORM, right? Okay. Okay, I think, yeah, you got it. It converts rows and columns into objects, and it makes things easier for us. So yesterday what I tried to do was, I tried to build this endpoint. I have an endpoint that says post. It accepts post on /users. So when you go to your browser, how it would look like? It will have https:/localhost on port 5000/users. So whenever you give a post request to this endpoint, by giving these two information, this information gets written to the database. And I think it's pretty obvious when I show the code. So you have Prisma. This is the object that you would probably use to infer Prisma wherever in your project. So let's say you want to create a new user. So I told you we have a schema, right? A schema is basically the skeleton of your database. It's more of the plan of your database, blueprint of your database. So we initially built a schema. We started drawing the schema. We sketched a plan and we put it into the database, right? Yesterday we opened Beekeeper. We created a new table, and on that table we created a few columns, and those columns were it was ID and it was phone number, right? If we had name, we had phone number, and we had ID, right? This is what we created yesterday. And at the moment, immediately after I put this command npx prisma db pull, and just know this command prisma db pull. Okay, Prisma is your script and you're gonna perform db pull operation. So what this essentially does is it talks to the db, it gets the schema, it gets all the blueprint, it maps the database. Okay, it gets all the information and it creates a model on behalf of you. Okay, in those days, in olden days, you would be doing this process. You would create a new model file. This is basically called the MVC architecture. So if somebody is into deep tech, they might have come across this term MVC architecture. Okay, in these all these enterprise grade softwares, where these softwares serve millions of people, right? So they need some sort of a rigid structure. You cannot start writing your code in a single file and expect it to get deployed on the web, and that doesn't work that way, right? So you have Facebook. Facebook is a very big product, and in order to develop Facebook, they need to build a rigid infrastructure. They need to build a proper project structure or a software architecture in a way that it's able to withstand a long running development, right? So that's why people usually prefer this MVC architecture. MVC architecture is nothing but models, views, and controllers. Okay, the entire project is basically abstracted. The entire software is basically abstracted into three parts. Okay, one would be your models, one would be your views, one would be your controllers. We will be talking more about controllers in a future, in a few minutes. But just know this. Whenever I say model in an MVC architecture, in a software architecture, I refer the database models. Model basically means how you see the data, in a database, right? I have users table, and whenever I say I have a users model, it means that I model my database to look like this. So my users table will have an ID, will have a name, will have a phone number. Am I being clear here? So do you get what model is in MVC architecture? Model is basically abstracting your database to look to perceive it in our project, right? Am I being clear?
Yes.
Okay, this is not just for Prisma. This is the entire MVC architecture I'm talking about. This used to be done by all those old developers, or you can probably say boomer developers. Okay, so these old people this is still in function, and a lot of enterprise grade companies, they build their own models, and this model writing part actually involves legitimate people who write models for their database. So that's why these people have database engineers, right? We are talking about backend developers, we are talking about backend engineers. We ourselves are trying to get into all the nitty-gritties of the software. But if you take all these enterprise grade softwares, that's why these people have a database administrator, they have a database engineer, and the role of this database engineer would be to model the database, write models, and do stuff like that. But in our case, with the help of Prisma, a tool like Prisma, things became easier. I need not write model, I need not model the database myself. Instead, I just create the database one time. I have a database, I prepare the schema over there, I just put this command npx prisma db pull, and at the very next moment, it talks to the database, does a literal scan on the database, and it is able to generate the models on behalf of me on the schema.prisma file, right? Maybe I'll show you live demonstration of, maybe I deleted the users, and again when I do npx prisma db pull, it talks to the database, it introspects the database, gets the information, the schema, and creates a model on behalf of me. It created, right? Is this process clear? This is very important when you handle Prisma. Is this process clear? Everybody? Okay, I'm gonna say model. Is it clear? Cool, right? So after I create my model, it's easy for me to infer that model anywhere in my project. So I told you, after creating a model, the next step would be to create a client, right? You would use this client. Client is basically a bundle of code that gets generated for you to basically use as a module, right? So if you notice at the top, I don't know how many of you pulled my repository and had a look at it, because I sent it in the afternoon. So anyway, just look at the screen. If you notice, there's this line, right? I'm basically importing a Prisma client, and this Prisma client is not something that I do npm install and install it from the npm repository. No, it's not that. This client gets generated whenever I do this command npx prisma generate. Okay, when I enter this command, the Prisma CLI, the Prisma tool, reads the schema.prisma file. Okay, it reads this schema.prisma file, and it generates the client for us. It generates this module, this module for us. So if there is no module, you wouldn't probably be able to use this Prisma client in the first place. So I do npx prisma generate. It takes in all the data from the schema.prisma file. It generates the client for me. So when you have a look into the client, you might know, you will probably find this. See, you have all the methods that we can perform on the database. You have users.create, users.update. You have, let me just quickly get it. Yeah, so it basically creates all the methods or actions that I can perform on the database. Again, this task was also used to be done by actual developers. People will write binding codes, binding functions that will talk through the models to the database. Okay, again here Prisma makes it easier for us. It creates the client on behalf of us. It creates a client and generates a client for us to use it anywhere. So after I do npx prisma generate, this client file would be generated. And why would it be generated? It would be in somewhere in the node modules. Of course, you don't touch node modules, it's there. Okay, just a quick recap of what we were doing here. So whenever you do Prisma pull, the first step would be you creating a database schema, right? As a developer, you would create a database. and you would create a schema. And the next step that you do in Prisma is you do Prisma DB pull, that is npx Prisma DB pull. After doing Prisma DB pull, Prisma talks to the database, it reads the schema, gets the schema and puts it somewhere in the schema file. And whenever you make any updates to the schema file, you can again revert it back to the database. So there's another few steps, but we're not going to get into that. So I hope everybody has a decent idea of what we are doing here and what Prisma aims to accomplish in the project, right? And whenever you do npm npx Prisma generate, it talks to the Prisma schema, generates the client and gets it back to the folder. So I hope I'm clear. So after creating the Prisma client, you have to initialize the client, right? This is normal. We always, whenever we import a module, whenever you import any huge bundle, you would probably initialize it, and we did that. And coming over to the important part, this is how you manipulate the data in the database. So you have Prisma, the client object, the Prisma object, and inside Prisma we defined entities, these resources. Right now the only resource I have in the database is the users table. So I have prisma.users, and what are the operations that I can perform on a database. I told you in any database you can perform a create operation, you can do a read operation, you can do an update operation, you can delete things on the database. So this is pretty straightforward. You do prisma.users.create and you put in the data that you need to put in it. Okay, so if you notice again, I have the schema. So whenever I give a request to this endpoint with this data, name and phone number, it should create a record in my database. Shall we try it? I mean, so far is it clear? Okay, so how do I test this endpoint? Anybody, can you guess? We've been doing it for a long time yesterday. How do you? Postman, right? Postman is an API tester. It's basically a front-end simulator. You can call it a front-end simulator. Or yep, we'll try Postman. And note down the endpoint. The endpoint is /users. So we have /users, and I have my name. Let's say I am Super Skywalker, and I'm gonna give some phone number, right? And if you notice, I didn't give any ID, right? Did anybody notice? In our schema, we had a column that says ID, we have a column that says name, we have a column that says phone number. Can anybody guess why we've not defined an ID in the endpoint?
ID is auto-generated.
Auto-generated. It not exactly. There's another word. Auto increment. Perfect. So when we created our initial schema, we defined this column to have an auto increment feature, an auto increment attribute. So even if I don't give an ID, even if I don't define an ID, it automatically increments. So it starts from 1, and if there's already a record on the database that starts with 1, the new record that's going to be created consecutively will have probably 2, and afterwards 3, 4, 5. It auto increments, right? This is a common feature in SQL linear data records. So we made use of that. In other cases, even if you want to create your own ID, let's say your ID is not going to be 1, 2, 3, 4, 5, and you want this ID to be a hexadecimal an hexadecimal array of characters. It should be a string, right? You have x, y, z, 1, 2, 3. It's a combination of. In those cases, you use a different ID, right? So we will be talking about that. You cannot do auto increment over there, and yes, we will do that. So let's try this endpoint. So I have a name, I have a phone number, and I'm going to send a request on the post endpoint, right? of course I didn't start my server. I do npm start, and it has started. I go to send, and my created record got returned, right? And you might ask, how is it returning the data that got created, right? Whenever you create a database, an entry in the database, this method returns the created data. Okay, we created a data using these attributes, and of course ID is generated by the database for us. And after doing that, the newly created record gets returned by this method, and we are just making use of that feature to send back as a response. Are we being clear here? This is basically the entire usage of Prisma. This is how you use Prisma. Okay, am I being clear? I mean, is anybody here?
Yes.
Okay, cool. So let's get going. If there's any doubt, just stop me right then and there. We can solve it. Okay, if you notice, there's one problem here. Okay, well, it's not a problem, it's more of a feature request. I want to be able to monitor my API requests at the server, right? So far I gave a request, and it kept loading, right? It kept loading. So I again give a request, it keeps loading, and if it fails, it fails. I don't have anything to be logged in the server, right? And even my request didn't get logged. In most cases, in most enterprise grade softwares, you need to build a logging mechanism, right? You need to know which people pinged your database. You need to know from where and all you got requests to your endpoints. So to do that, we will be doing something. We will be building a logger. Okay, a logging mechanism is very, very important in any backend. Okay, and usually you will have usually you have other pieces of modules or softwares or libraries that take care of this. We will try implementing a logger of our own. Okay, or let's do something else. I'll just quickly tell you how a logger works, so that you get a better idea. So the logger that I'm gonna use is Morgan. Okay, so if anybody is following with me, you can of course install npm install Morgan. Okay, Morgan. So when you do npm install Morgan, it gets installed. So you will be importing Morgan in your file. So after importing Morgan, we will be using it as a middleware. Morgan is a middleware. Again, we will not talk more about middleware now. The next topic is middleware. We will get there, but just know this: middleware is a middleman, and so whenever you send request to an endpoint, this guy takes your request, does something on the request, and send it back to the route, and the route handles your request and gives you the response, right? So we know what's a middleware is. And to use Morgan, the logging mechanism, you do server.use. It's simple, Morgan. And of course, you have an option to set what type of logging you need. The most common logging mechanism is dev. Okay, so when you give an option, this is totally optional, but when you give dev, you get more information, more log information, like what sort of request it was, what was the request content length, and more information. So I think you get it. So when you don't give it, by default it's just production, and in production you don't need to know a lot of under the hood stuff. So I'm gonna save it, and now our server should start using Morgan. npm start mod. Okay, I think I did.
Morgan, right?
Yeah. Thanks. And I restarted, and yep. So now I'll try giving a request. I send a request. Did you notice? Now my request got logged, and this is very, very important when you start building your backend, because you need to know which endpoints were essentially pinged, and if you want to probe into what went wrong, you need to know which endpoint might have gone wrong. So this is how you do it. Now you are able to identify which client or what sort of request basically the user tried to give to us, right? And what was the status code that was sent back to the user, sent back to the front end, and how long it took to complete the process. And if you see this, if you can interpret this, you have 3079 milliseconds. This is totally not good, because when you convert it into seconds, it's 3 seconds, and any endpoint shouldn't take more than, you should try to minimize the processing time at the backend, because you have network bandwidth time, and if you take the backend itself taking almost 3 seconds, and if you add and subtract all the time that it takes to reach the backend and back and forth, this is really bad. So as a backend developer, you should be able to identify these potholes and try to fix it now and then. And the other parameter that you get at the end is the length of the request object that you send. So I'm gonna send it back. So you will notice that it doesn't change, right? The request body, the payload, has a fixed length because I didn't change any length. So this is it. So that's how you log. So now let's get into middlewares, right? We've been talking about middlewares and how these middlewares take the request object, does something with it, probably print it on the console, and sends it back to the route, right? Let's try building one middleware ourselves. And can anybody give me an example of how we can use a middleware? You know how a middleware works now. Can somebody give me a use of a middleware? Maybe you can give me a custom example of why you can use a middleware. It can be simple. It can be as simple as finding a prime or whatever. Can somebody help me? Why is nobody talking? Is everybody here?
Yes.
Okay, cool. Okay, let me give you an example. Okay, let's build a middleware and let's use it right away. So you have the user's endpoint and you have a phone number. So let's say whenever you store the phone number in the database, you want the country code to be you want the country code to be prepended to the data, right? You have the data, you have my phone number 899624666 or whatever, 875, but you don't need this. You need +91 to be prepended to the number. Okay, usually what you do is you would probably do the change on the front end. So let's say I want that to happen. I'd probably change the data which is going to the database. Instead, the more versatile way to do this would be, even if the front end guy fails to do this, you can probably build a middleware that takes care of this, right? So whenever a data of this sort comes in, you check for the phone number, you probably check, or you don't check, you just prepend this country code to the front of this phone number. This is one example of using middleware. So maybe we'll try to build that. Okay, A middleware is basically a function, guys. It looks similar to how an endpoint handler looks, but let's build it. Okay, you define a function. A middleware is basically a function, and let's call it add country code. Okay, it takes in 3 parameters. One would be the request. It's gonna perform the operation on the request. It takes in a response, and the third parameter is next. Okay, I'll talk about next, and yes. So what we are trying to do here is we want this phone number to be prepended with a country code. So how do you get that phone number? Can anybody guess? Where would the phone number be? I have 3 parameters. Where would the phone number be?
In the request.
In the request. So in the request, where would it be? Request is basically a nested object, right? So it's just a request object. Inside request, where would my phone number be? In a body. In a request, you have a body, basically the payload, and there I could find my phone number. So now it's pretty simple, right? You have the phone number, you prepend 91, probably India's country code, and you put the same phone number. Does it make sense?
Yes.
Okay, and after doing this, you call the next function. I'll tell you what this does. This next parameter is basically a function. It's more of a callback to the original endpoint. Okay, so after completing your process, after doing whatever, adding masala to your request, you take that request object and send it back to the intended route. So to do that, or to pass on to the next route it was intended to, you put next and call that function at the end. Okay, so this is middleware. So this is what a middleware does. So right now you might have guessed what Morgan would have been doing. So can anybody guess? Can anybody explain what Morgan does? Now you know how to build a middleware. Can anybody get me through the process of building a logging mechanism? Can anybody give it a try? It's pretty simple. You have the answer in front of you. Can somebody try? I want a middleware that logs, that basically does what Morgan does. Can somebody try? Anybody? Or should I call out names? Come on, just try, no? Okay. I mean, it's really silent. I need somebody to talk. Abhishek, choose somebody.
நான் சூஸ் பண்ணணுமா?
Yeah.
ரோஹன் ஜெபு.
Rohana. Hi Rohan. Rohan இருக்கியா? Okay.
Anna, I have a doubt.
Yes.
Like, what if the country, what if the phone number already has +91?
So what you do? You give me the answer. So what you do?
So maybe we do a if else.
Exactly. You do that. You do a check. It's basically you test for the required, structure of the data. If it doesn't match, you can probably exit right here. You can probably call the response object and throw an internal server error to the front end, right? So this way you are stopping the execution of the handle right here. So without even going to the endpoint handler, you will check if the country code does match, and if it does not match, you straight away send an internal server error and you throw an error so that the front end is not able to, it knows, right, it made a mistake by sending a wrong phone number. So you can do that. You can test, you can write if statements, you can write switch statements, you can do everything that you need to do. You put all that masala in top of the middleware. You use middlewares for that. And of course, okay, I'm gonna proceed with writing the logging mechanism. So let's say you need something to do similar to this. Okay, you need a logging mechanism. So this is how you do it. You define a function, or I don't want to waste time on this. Maybe you guys try to do it on your own. Okay, maybe I'll put it as one of your tasks. So anyway, I think you get the idea, right? Everybody, middleware. Middlewares are very important when it comes to ExpressJS. So yep, if you have any more doubts, please let me know. Okay, cool. So let's get on. Okay, another very important middleware that you would use in development is Helmet. Okay, it's another module, and I would highly recommend you use this. So you do npm. We're gonna install a lot of modules here on. Okay, so just stick with me. If you have any doubts on what these modules are, I'll of course talk about what this module explicitly does, and if you have any more doubts, I'll clear it at the end. Okay, so you do npm install Helmet. I'll talk about Helmet, what it does. So I told you Helmet is another middleware. So let's import Helmet. I imported Helmet, and I use Helmet server dot use Helmet. Okay, Helmet is basically Helmet. So you have a request object, and you send back a response. When it comes to the internet, right, this request and response object has a lot of information, not just your request payload, not just your header and things like that. It has a lot of security policies that we talked earlier in the first session, right? It has CORS, it has whether it can allow pings from a different server, whether it can allow data to be in this form, whether it can allow JSON data type, all these policies, all these security policies, all these header information, right? All the basically Helmet of your entire request, Helmet of your entire response. Helmet basically takes care of doing that for you. Okay, instead of you putting in all the header, setting in all the header attributes, you take Helmet and it takes care of that for you. So I'll maybe so yeah, you had a request object, you had the payload, and you have header informations and all the other security policies on any request object. Okay, there's something called CORS, there's something called a lot of other policies, and these policies basically govern how a request can be sent to a server, and whether a request can be allowed from a particular IP, or whether it can be allowed from a particular domain, and things like that. So these are basic policies, and Helmet basically takes care of that for you. So in any project, I highly recommend you use this Helmet, so that the people who use your APIs in the front end, they shouldn't come across any problems, because in some cases when you deploy your API on the web, the front end client would not be able to access our API just because of some security policies, just because some headers were not present on the request. So Helmet takes care of that. Okay, and the other important very commonly used middleware would be serving static files. Okay, all the middlewares would be used, right? So of course you implement it using the use method, and this middleware is inbuilt in Express itself. So you do express.static and you say public, and where you use this. In most cases, in some of these servers, you would come across the requirement of hosting images, hosting static content, static HTML files, not any nothing dynamic of sorts, right? So let's say you have around 50 images or anything to be served on this web server. A web server should be able to serve anything, not just endpoints, right? Commonly, you would set up a folder under the name public, and anything that you put inside this public folder now gets hosted, now gets served by our web server, right? So let's try that. So I have some file. Let's say I have this GIF. Let me quickly paste it into the public folder. I'm gonna call it sherry.gif. Any file, right? So I'm gonna start the server, and it's working. So I head over to the browser and I do http localhost I don't know what I'm doing, and you say sherry.gif. It's now being served from our web server, right? And this has a lot of potential, because you would probably need to serve some static content on your web server rather than dynamically routing it. So even if you have any HTML to be served, you can do that via this public folder, and all the HTML that you put inside this public folder gets served without any routing or anything, right? Are we being clear? We saw Helmet, we saw Morgan, we looked at the static middleware. Are we going clear here?
Bro, how was the public folder created?
We created the public folder. We created a new folder and put whatever files that we need to serve by our web server. And in order to serve this public folder, you use this middleware, server.use, and our middleware is express.static. It's one inbuilt middleware given by Express. So you do express.static, and whatever parameter that you give into it, this is basically the folder's name that you would like to serve as static. You did that, right?
Yeah.
Cool. Is there any more doubts in this? Are there any more doubts? Cool. If there is none, we'll proceed. Okay. Another important this is a very fundamental concept where you talk about dynamic routing and endpoints. Okay. So far we were able to route certain endpoints. So let's say you sort of wanna get resources under users and get all the documents that are available under users. So what you do, you create an endpoint, and I'm gonna say it's a get endpoint, and usually when I need a resource that is relevant to another resource, I would nest it when I route it. So I have users/documents. It's pretty obvious, right? Whenever you need to get documents under a user, you would build your API in a way that the route is nested, right? Isn't this common? So you do something like this. You have users/document, and this is how you statically route endpoints. So inside, you know what you would be doing inside this endpoint. inside the handler, you'll talk to Prisma, talk to the database, get all the matching records, matching documents under the users, and send it back as response. You know that part now, so let's not worry about it. So far we've been looking at all the routing and all different methods that we can talk to an endpoint and how we can do that. Now let's get into another concept called dynamic routing. Okay, dynamic routing is a simple concept where you talk to an endpoint, you pass data, you get to query resources directly from the route, right? I'll show you how. So you have users, and let's say you have a dynamic route that goes under the name ID. You have the request, you have the response, you handle that request response, okay. Yes. Yeah. So basically, this ID, the ID that comes under your route, is a parameter, and you can use that parameter to get things from your database, right? So that's what we're gonna do here. So let's try this endpoint. I have an ID that goes under 12, so let's try to get 12. It was users /ID. I'm gonna start the server. After starting the server, I get back to the Postman, and now under get endpoint, under users, and here's the dynamic routing. So my user ID was 12. So instead of giving it as a query parameter, instead of giving it as a body payload, I infer it directly on the route, right? So my resource is dynamically routed through this route by using dynamic routing, and basically you can access this value using request.param object. These are parameters, and this is how you use it. So I try giving a request. Now we have let's do something else.
It's Prisma.user, not user. Our connection name is
Oh,
user.
shoot, yeah. Thanks for pointing it out. Yeah, just make sure that you use the correct model, because you might be suffering you will find a hard time figuring out what went wrong, and it would be a simple fix in referring the name. Yup. Yup, we got it. So whenever I request under the dynamic route 12, I am able to receive the user object. I found it from the database and I was able to return it where the ID matches the request parameter, right? So that's how you dynamically route. Is there any doubt in this? No. Do you get how you can dynamically route resources? And you can further nest more routes inside this. You can have documents under a particular user. So yeah, so this is how you dynamically route. So if this is okay with you, let's get on to the next concept. And should we take a break now? Is it time? Jacinto?
Yeah, I guess it's time for break.
Cool. Let's take another 5 minutes, a quick 5-minute break, and let's get back, with a fresh start. Okay. And when you come back, we will be building a fully functional API. We will be starting our API, and so be ready. So get your VS Code and things ready if you haven't done so far. So this is where we actually do hands-on API development. And yep, we have and next we will be getting started with TypeScript, so get ready. Yeah,
Yes.
cool. Get back in 5 minutes. Hello.
Yeah, Phoebe.
Yeah, perfect.
Yep, we can start.
Yeah.
Yeah, we can start.
Okay,
Take
okay, okay, okay. Is everybody here? Just give me a
Yes,
yes
yes.
if you're here. Quick react. Okay, we have a few more concepts in APIs before we get into TypeScript, and after TypeScript we straight away get into building our API and providing authorization to it. Okay, shall we get started? Cool. You're back, right? Can everybody see my screen?
Yes.
Perfect. So the next thing that we are about to do is the second part of the MVC architecture, the controllers. We talked about models and how you can abstract database when it comes to project management, when it comes to developing your software, developing your app, right? So now we are going to understand what these controllers are. Okay. So in MVC architecture, you know, models and controllers basically are the actions, are more like these are functions. These are operating working part of your software. So this is why you write your logical code of probably talking to the database or generating a view or things like that. Okay. So in any MVC architecture, the controllers have a very important part to play. So these basically perform all the business operations, perform all the main logical operations of your entire application. Okay, so now you know what an MVC architecture is. Models take care of your database. Views are basically what you generate. You give back a rendered HTML page. You call that a view. You get something for the user to view. You call that a view. And we now know what a controller does. It basically, this is where you write all your logical operations. Okay. So when I say controller and explain, give you this huge explanation, it's not really something out of what we're gonna do. It's right here in front of us. We've been using controllers without even recognizing it. Okay, I'll show you how a controller would look like. So you have a request handler, right? You call this a request handler, basically an endpoint handler. So this is how you handle a request. And controllers are basically functions. Okay, so let's say you have this endpoint which basically gets information upon giving name and phone number. Okay, I'm gonna take this function. I cut it, so there's no function here. Let's say it was an unnamed function, right? Before it didn't have any name. It was an unnamed function. So now let's say I'm gonna give it a name. I'm gonna call it probably get or get user. Okay, now it's a function and it's a named function. Now instead of putting this unnamed function over there, I'm gonna use this named function. I'm gonna call this controller, and yes, so this is basically what a controller is. And why would you isolate your operation in a different function? Why would you call that a controller? Can anybody give me a guess? Why do I do this? Any guess?
Reusability.
Perfect, exactly, reusability, right? So once, if I have this one controller defined over here, I can have as many as routes I need, as many as, it's similar to middlewares, where you can probably do something out of it, right? So this way, there's one catch here. One is reusability, like this guy told. The other thing is in actual development, in actual backend development, all these routes would have to properly be organized in a structure, so that any developer would be able to understand what you're doing there, right? So imagine you putting a bunch of handlers on every single routes. So if I need to find any route, it's really inconvenient. Okay, so to solve this, usually when you structure your project, you put all these routes, all the endpoints in one file, and you put all the controllers in a different file. You store controllers separately, you store routes separately. So whenever you need to define any routes, you take these controllers and assign them to a route. It makes sense, right? It makes sense when you use these controllers and assign them to a route. So these routes basically are the endpoints to these controllers. So that's why you call them an endpoint. Am I being clear? No? Do you finally get what's happening when I talk about APIs and endpoints, routes and endpoints? We'll further split all the routes into controllers and routes, but just know this is how you declare a controller. Are we clear?
Yes, Fabi.
Perfect. Okay, now the final part is routing, and okay, let's not get into routing now. Let's get into error handlers. Okay, I'll show you another example of where you might face this problem. So I'll save it. So far we've written 3 endpoints. We have /user/user/id, we have cars, and the base route, just slash alone. So I'm gonna try another endpoint. Let's say I try to ping this endpoint where there's no route for that endpoint. So let's try doing that. Now I'm gonna try fruits, and this resource is not available on my server. It's not being served. There's no route for this resource, or there's no controller for it. There's nothing. So when I try to hit this endpoint on my running server, let's see what happens. You can see, right, it threw us this error, this inbuilt error. But let's say it got me information saying that it could not get fruits. And the other important thing that you must notice in any response object is its status. Okay, in HTTP, along with the in HTTP request, you have these HTTP methods, right? Similarly, in any response, in any HTTP object, you have a status parameter which talks about what status it is in. Okay, most commonly used statuses are 404 and 500. Okay, so whenever you come across 404, it means that somebody tried to talk to the server and they couldn't get something. They couldn't find a resource. A resource was not found. In our case, we tried to talk to the server and get fruits endpoint, and we were not able to find we were not able to find the fruits. So the server handled it and threw me a 404 error. Okay, this is pretty obvious. And let's say you have some database error, or let's say you missed some colon or a comma in a particular line. It's basically a problem with your server, right? It's an error in your server. How will this front end, how will this client know, and how will the client be able to identify if something goes wrong in the backend? So that's why you throw an error called an error status code called 500, right? 500 is basically you mean that something went wrong in the server. So whenever you decode this entire testing, this part is very important when it comes to testing. You read the status, you identify what might have gone wrong. So 404 means not found, and 500 means something went wrong with the server internally. Okay, and right now, let's say I make some change in here, or I try to divide it by divided by 0. Okay, I think it should throw some prop. It was get user. Wait, okay, never mind. So let's say you have some error in your code and you ping that endpoint. So you would normally get a 500. So I just want you to know that you can find information about your response through this through the status object, and 200 means it's found. And like this, there are like a huge list of statuses that you intend to send it back to the front end. So these are standardized so that the front end developer knows, okay, it's 404, and this would have been the mistake, and he would be able to fix it. So that's very important when it comes to HTTP statuses. Okay. And that's all about error handlers and error handling. If you want to get more into error handling, or if you want to do something else whenever a particular error gets thrown, let's say you got the error status 500 and you don't know what's happening in the server, right? You can also get information from the traceback, so that you send this error back to the front end, so that the front end developer knows, okay, this line has a trouble in the server, so particular attribute needs to be changed. So this is how the front end developer would be able to communicate to the back end developer. So see, I got this error in the front end, please fix it. So this is what, as a back end developer, you should be getting into all these error handlers further. So yep, that's that. And now we are going to get into TypeScript. Are we ready? So far we've talked about APIs and we've almost completed everything, and everything we have, everything basic that you need to get started while building an API. So shall we get going with TypeScript? Just let me know if you have any doubts. Why am I getting only 6 reactions? We have almost 27, and cool. Let's proceed. Okay, so this is more of a story, okay? And you have TypeScript. So talking about TypeScript, does anybody know what TypeScript is? Can anybody set the context here? Has anybody heard of TypeScript? Yeah, so what is TypeScript? Okay, I mean, what it's used to define types, but what is TypeScript?
Superset of JavaScript.
A superset of JavaScript, perfect. The story behind TypeScript goes way back, a few years back, okay? So the thing is, JavaScript is a very loosely typed language. You don't have strict constraints when it comes to identifying errors. When it comes to types, it's not strictly typed. It's not a strictly typed language, okay? What do I mean when I say a strictly typed language? It means you have basic data types. You have numbers, you have strings, you have all these small primitive types. But in JavaScript, if you notice, if let's say you have a number 5, a variable which holds a value 5, or better, I'll show it on screen. You have a variable which holds the value 5. and you have another variable which holds 5 but as a string. Okay, I try to add A and B. So what would be my output? Of course, this is a number, this is a string. Can we get an answer? So my answer was 55. Okay, the problem here with JavaScript is it doesn't know how to treat a data type. It doesn't know how to treat a variable. Okay, it's not strictly typed. Even though I try to add a string with a number, in case of Java or any other strictly typed language, you would probably be thrown an error. You wouldn't even be able to compile this, right? But in JavaScript, it's strictly compiled. It means, it's not strictly typed, and it means that you can add a number to a string. You can come up with a lot of different things, and it still work. The code will still work. It won't really throw an error. Okay, and when it comes to basic playing around with JavaScript, or when it comes to scripting on the browser, it's okay. Of course, even there you have sort of problems where TypeScript comes in, but in most cases JavaScript thought it was okay. But when it comes to backend development, it's very, very important that you get the right type of data types. Okay, you cannot give a number as a name. Let's say I'm collecting a user's name. You cannot say get me I cannot set 5 as my name, right? It doesn't make sense. And it's very, very important that my language, the language that I use to program my backend, is a strictly typed language. It has types, so that I am able to find errors and say tell back to the user, see, this is where you went wrong, and this is how you fix it. And in this line, you in the future you would have some problem, so don't do this. So TypeScript makes things easier for you. It basically adds in a layer on top of JavaScript. It's basically JavaScript. It acts as a superset of JavaScript, why you have types now. Okay, are we being clear here? Let's look at a few examples of where it can actually be used. There are different ways you can use TypeScript. We will be using it minimally. The ones who have already started working with TypeScript, I think the crew who would be working with Cortex, you must have come across TypeScript, right? So it's not really as complex as using TypeScript on the front end, but you need not take it lighter as well. So let's look at how we will actually start using TypeScript. So quickly undo it. Just give me a quick second. So let's start using TypeScript. Okay, to get started with TypeScript, the first command that you do is install TypeScript on your computer. So to install any module, TypeScript is available as a module. So you do npm install -g. So -g means you install TypeScript globally, not just on this project. You install TypeScript globally. And after you've installed, you have something called the Typescript Compiler, TSC. Okay, this TSC tool basically acts as a compiler, and you know what a compiler does. It takes in one form of language, it converts a language to a machine readable code. You know, it transpiles it, it compiles it from one form of language to another form, right? So when it comes to TypeScript compilers, I told you it's JavaScript. I mean, TypeScript is basically JavaScript with a few overhead tasks on top of it. Okay, so this compiler basically converts your TypeScript code back into JavaScript. And I told you TypeScript is used in development so that you don't come across any error in types. And after you compile it, it goes back to JavaScript. And we need JavaScript because your Node.js, right, your runtime environment, it can only understand JavaScript. So far we've tried Node space index.js, and we were able to run a file in Node, right? So in order for your Node to understand what this TypeScript code means you would compile it back to JavaScript. To do that, you do TSC. So this compiler takes care of it. So in order to initialize this TypeScript environment inside our project, you do TSC -init. You might notice once I did that, there's a new file in my project directory that says tsconfig. This is basically a TypeScript configuration. Okay, there are a few setups that you would probably do in any development environment. We'll just skip that part for now. I'll talk about the configurations later. So let's start using TypeScript. Okay, normally in any config I would use these, and I think let's not get into the nitty-gritties of what this means, but yeah, this should work. So I create a new file, and TypeScript files end in the extension TS. So let me define a new function, and let me call it add numbers, and let's say I given A and B. This is a normal JavaScript function. Do you see? You don't see anything new over here. Okay, so let me call the function. But when it comes to TypeScript, here's the catch. I told you it's a strictly typed language. It means that every variable that you declare, or any parameter, or any symbol that you declare in your file, it needs to have a type. And let's say there are basic primitive types in TypeScript, and the most commonly used types are string, a number, and an object. And TypeScript also gives you the option of using any. Any is another primitive type that basically means nothing. It's generic. It's a generic type. So to add numbers, I would probably need number, and both of my parameters would have to be typed. So now I try to add 1 and 2. Immediately whenever I say 1 and 2, I try to add 2, you can see that it throws me an error. argument of type string is not assignable to parameter of number. I told you in backend development, it's very important that you have types so that you restrict people from writing wrong types of data into database, right? So this is how TypeScript comes in handy to us. So do you have any questions in what we've done so far? Of course, when I do string, the problem solved. B is a string and it's able to, I'm able to use that module like this. Okay, do you have any doubts?
So we can still add numbers and strings in TypeScript.
Yes, if you require to do that, if you want to do that, but it's
So
totally, yeah,
So here the output would be 12 as a string.
let's try that.
Is that what-
Let's try what's happening. I'm gonna say TSC. Yeah, somebody trying to talk. I mean, is somebody trying to talk? Crispin?
Sorry.
Okay. So I told you, in order to compile a TypeScript file, you do tsc and that file's name. So I say index.ts.
So then you need to save the file.
Yep, thank you. I do tsc and index.ts. So the very moment I did that, oh shoot, it's okay, my index file got created. And if you notice, the compile file doesn't have any type iterations, type declarations, right? So basically, just know this, all your JavaScript code will work on TypeScript, but TypeScript is a superset. There are a few exceptions that you cannot include in JavaScript. So like when, I don't know who asked this question, but you asked if you change the data type and will you still be able to run? Of course you will be able to run because you made this change, right? You, one sec, okay. Yep. This function that you wrote, you wrote some types and you declared a few types and you made it, right? So you have declared B should be a string and A should be a number, and you did this, and after you completed compiling it, it goes back to JavaScript, and we looked at JavaScript and it didn't have type, and JavaScript basically will still be able to add two numbers and a string, so you would probably get 12 as an output. Okay, you should understand that TypeScript only helps you during development, and that's why you add TypeScript as a dev dependency. Okay.
Okay. So the function of TypeScript is to like set a constraint on a variable about
Constraint
what
on a
type
variable
that-
about exactly, so that you don't
Okay.
have trouble when it comes to production. So now already you have sort of a setup which actively looks for types, right?
Yes. Okay.
Perfect. In TypeScript, there's another cool concept. Okay, I think many of you know this, a JSON notation, right? You have a variable, probably a user variable, and it's a JSON object. And let's say I have name and I have age, and that's it. And let's say I have phone number. All right, cool. So let me try to assign, or let me just do it on a live compiler. So we can see that I declare an object with all these attributes. Okay, now I compile, I log it, and I'm able to get that. So let's say I add in some new attributes to it. So let's say I have user dot id equals let's say there's something or some gibberish. Now I try to save it. You see that the user object now has ID, but initially the user object was supposed to have name, age and phone number. It's okay here, it's okay that we try to add a new attribute and set value to it. There are cases that you might need something like this, okay? But when it comes to database, let's say you have a model and that model needs to be consistent with the database. Our database has columns that says ID, name and phone number. It means that I cannot have age, right? That's wrong. It won't work. If I'm trying to push this user object into the Prisma database that we were working on earlier, will it work? Any guesses on what error it would throw? I have this user object, I have name, I have a phone. In my database, I have name and a phone. I try to push this object into my database. What will happen?
Something like the attribute age is not available.
Exactly, age is not defined in the schema, so it would throw me an internal server error, right? So during development, you could have probably checked if this user object has this attribute called age or has these attributes, name and phone. You should restrict the developer in a way that you don't exceed these constraints, right? This is where you introduce another type, another concept in TypeScript. These are called interfaces, okay? An interface. A TypeScript interface is basically a schema for an object. So it's like a blueprint for an object. So you have this user object, but you don't want this user object to be to contain any attribute. Let me do it quickly and explain what's happening here, okay? I'm gonna try declaring an interface. So let's say my interface is gonna be called a user interface, and let's say my name would be a string, and my phone again it would be a string, and my ID would be a number. This is how I've defined in my database, okay? Now this is not just any object. Let's say I type parameterize it, I give it a type. This user object is gonna have user as an interface. Now it checks with this interface, it checks if this type matches with this object, and now we are able to stop before even pushing it into the database. Now we stopped an error from happening in the first layer of abstraction. You have an API layer, you have a DB layer, and you have the user layer. We were able to stop the error from happening just right in the API layer, right? So this is how interfaces can be useful when it comes to TypeScript. In most cases, whenever it comes to backend development, just using types and interfaces alone would probably get you started. That's all you need for getting into backend web development, right? That's all the TypeScript that you need. Of course, you would probably need enum. There are a few other concepts in TypeScript. Those are very straightforward. When I give you the task, you would probably get to know about it. You would probably refer the documents. I'll be sending you cheat sheets that you can refer to. So that's it. It's very simple. TypeScript is not really much of a big deal. So don't get overwhelmed by TypeScript. Now you know what TypeScript essentially does. It helps you reduce the number of errors that you have during development, right? And the other cool fact is 60% of all your errors would be cut down when you start using TypeScript, okay? Because in most cases you would be scratching your heads not knowing what to do and where would the problem be. So TypeScript is strictly typed, and this, like, you've seen a working example of how you can save your code a long time of debugging, right? Is there any questions on what we've seen so far? We got started with TypeScript. Is it okay?
Yes, bro.
I mean, hereafter we will use TypeScript, and the task that I'm going to give you will require you to use more concepts in TypeScript. So these will be you learning a few more concepts in TypeScript, and it's not really necessary that you know the entire concepts, the entire syllabus in TypeScript. You just need these few concepts that will get you started. Are we good? So just give me a quick reaction so that we can move on to the API building part. It's almost time, and I wanted to get started with it. Shall we get started? At the end, all your TypeScript code gets converted to JavaScript, and yeah. So cool. Now you are going to start coding. I'm going to get you a quick boilerplate for you to get started with your API. So far we've seen a few concepts. We've understood what middlewares are, we've understood what controllers are, and we've understood how you route and things like that. So now I'm going to make you build your own project, okay? So I have made one Express TypeScript boilerplate before, so I'll be sharing it to you now. I want you to download it and put it in your project directory, okay? Just give me a sec. It's there on CoderStack. I want you to click on it, open the GitHub repository, don't clone it, click on code and download the zip, okay? Download the zip, extract the files in the zip, move it to your project directory. Remove everything that's there on the project directory right now and do this. 404.
I think it's a private repository.
Oh shoot, let me make it public. That should work now. Open the repository, don't clone it, download the zip, extract everything that's there on the zip, put it in your project. And before doing that, remove everything that you have currently in your project repository, okay? Completely remove everything. After you do that, give me a reaction. You download the zip, extract everything and put it right into your project folder. Can we do that quickly? We don't have time, so if you've done that, install the node modules. You do that by doing npm install, or you can just put npm space I. Just do this quickly. If you have any questions or if you are stuck anywhere, just unmute and ask it right away. Download the boilerplate, extract everything, put it in your project directory before after clearing everything that was already in your project directory. After doing that, install the node module. We have 2. I mean, can we make it quicker? I mean, is it taking too long to install the node modules? Please let me know, like, what's taking long. We have 17 completions. I mean, let's get started. Okay, now I want you to delete the schema that you already have in database. So you have an Heroku database, right? So you go and open your Beekeeper Studio. You drop the table. To drop any table, you go to the query tab in your Beekeeper Studio and you put this command. If your table name goes under users, you put drop table users. I want you to keep your table clean. I mean, keep your database clean. Okay. Cool. I'm gonna give you a quick overview of what we have here, and I think we don't have time. We don't have much time, so let's get started. So is everybody back on my stream? You know, have you completed the setup?
Yes.
Okay. So look, start looking at your project directory. Okay, so you need not worry about all these other files that say npmrc. These are files for different purposes. So for example, npmrc, you save configurations that pertain to npm, and it's relevant only to this project. So if you need it to have certain configurations, you do in these configuration files. Okay, so don't worry about it. Don't worry about the configuration files. Don't worry about the TypeScript configurations. Everything is pre-set up so that you need not set a lot of things. The thing that you need to get your eyes into is the source directory, right? This is where all of your code is going to reside. And if you look at the code, you have the index.ts. So this is going to be our entry point in any JavaScript, in any node environment, or in any Express app. It starts looking for an index, and this will be our entry point, the main entry point. Do not worry about other modules that you don't understand. So let's just quickly run by one file after the other so that you get to know what's actually happening. So you already know how you set up a server. You create a server, and you define the routes, and you start listening to it at the end, and you set up the exit signature and things like that. Okay, so this is quite familiar to you, right? But if you notice at the top, I've declared server. I've received server from a different file. Okay, I do this because of one reason. Okay, if you notice in our previous file, I think I deleted it. Let me show that on GitHub. Let's compare what's happening here. If you notice the previous file, you had index.js, and you were basically defining all the middlewares, all the endpoints on the same file. And when it comes to scalability, when it comes to huge enterprise grade softwares, you wouldn't do that, right? You need to structure your project in a way that it's properly relevant and accessible easily. So to do that, we set up all our server middlewares and routes in this file, in a file called API. You can of course give it any name, but usually since we are just building a backend, we're gonna call it API. And if you notice, I've imported all my middlewares and all the other middlewares that I need for a scalable project. So I've imported everything, and over here, if you notice, I've not done it using any basic. I've used classes here. I've used express inbuilt classes. So I've initialized an Express app using the object-oriented approach. So in any object-oriented approach, you have a constructor. You have associated interface methods. Okay, don't wrap your head all around it. Just understand that this is how we set up an Express app using an object-oriented method, right? You have declared a class. You have declared an app, and in any app, the first thing that gets called when you initialize an object is the constructor. And in the constructor, if you notice, we initialize the Express app. This should be very familiar to you because we've been doing this for a very long time now. So you initialize by calling the Express app. So you set the context and you do that. And if you notice, I have another method that sets middlewares for me. So it gets all the middlewares from which I imported, and it sets all the middlewares that I need. So this function takes care of all setting of middlewares. You should understand that this is very important because in any scalable project or in any enterprise grade softwares, you would have tons of middlewares. You would have many middlewares, not just 8 or 10 or 8 middlewares. You'll have 50 middlewares. Okay, so in order to handle that, you need to set up your structure in a way that it's able to perceive it. So that's why we define another function that takes care of handling the middlewares. And after that, you have the set routes. Okay, we saw express, you know, in our earlier file we saw this. In order to set an endpoint, you have server.post, server.get. So slowly we started getting into routing. Okay, this is another concept in Express. In any Express app, you would have a router. It's available in Express as a submodule. Okay, you use router to define any other routes that you need other than your actual endpoints. So if you notice, let's say you wanna declare your APIs in this way. So you have localhost at 5000, and let's say you wanna have /version1, and after that you should have all your routes, right? You need some sort of a previous header or a previous location, a previous how do I call it? Let's say you want some sort of a previous route to be handled. So you do that by routing it, and to route any endpoint to route it, you use the same use method. So the first parameter would be the route, and the second would be the actual router. So if you notice at the top, let's go to this file, API v1. I've declared a router. I think it might be, you know, ambiguous, or it might be confusing, but don't just worry about it. It basically routes, and it basically points whatever you have under this first parameter to all the other endpoints. So when I click on users, you have all these endpoints declared in it, right? So I can have users.post, I can have users.get, and all the other methods in it. So basically when I export all the endpoints to this router, it gets mapped to users, and that in turn goes back to API/v1. So at the end, when you refer it in Postman, this is how it would be. You would have v1, and you would have users, and you would have the endpoint, right? I mean, this is a very lot to it's actually a lot of things to take in, but just understand that you use routers to route it, to set a location on the server. Okay, so you map all the routers in a way that you set the first parameter, and this first parameter is how your API will be routed. So just go from the top. It's a top-down approach. You have the first file index, and you declare the server. You head into the server. You have the routes, and when you go into v1, this router, you have the basic users router. Like this, you can have any number of resources on your endpoint. You can have router.use. You might require another resource. Let's say you have projects under a user. So you will declare another user and declare all the projects and routes under the projects folder, and you start importing, and you will straight away use it as a router. So this is how you start routing your endpoints. I mean, this is not really easy to explain. I don't know, I'm not really in the mood, but let's say just have a look at this project file, and you will have a better understanding of routing more than me explaining it to you. So I want you to get back home, and probably by the next session, just have a look at what is happening under the API/v1 folder. Try to understand how these APIs are organized, how the entire project is structured. I want you to have a look at it, and I want you to start understanding what is happening. Okay, and after tomorrow's session, we will be building a job listing API. Okay, our API, I'm going to talk about what this API does, so that we'll wrap up the session for now. It's been almost 10 minutes way past, and I think it's starting to get boring. We haven't really started coding. So tomorrow when we get back, we will be building a job listing API. So this API would be able to accept job openings, would be able to accept requests from the user to create jobs on the backend, or to create applications, or to apply for jobs through the backend. So basically we will be building the backend for an app that is potentially similar to you have Indeed.com, you have Internshala, right? We are gonna build a backend for that. So get ready, it's gonna get more intense than this. So I want you to take this as a homework. You have the project directory, understand what's happening under the hood. 99% of all the things that you see here, you've already seen it in the previous sessions. We've talked about it, we've used it, we've declared it, we've done it from the scratch. Okay, so in order to get a hand on what these routers are and how you use routers, you have to probe yourself into this project directory and understand how it is wired. Okay, so I want you to do that. So over the next session, we'll get started by building the schema. We'll start setting up the API, and we should be done doing that. And to make things simpler, I will be building the schema for us, and I think all of us can use the same schema for our database. You need not worry about setting up the schema and doing it all by yourself. I will teach you how to set up the schema. That's a very simple way to do it. You need not worry about creating all huge tables and setting columns in databases and things like that. We need not worry about that. Okay, so tomorrow when you come, just have a look at the project. So I think that's all about what we did today. We covered middlewares, we saw what controllers are, we used a few modules, and we set up a basic project today, right? So, and another cool thing is you can use this project to basically build any enterprise grade backend. So it will still work. It's scalable, and it also has build commands and a lot more cooler things that you can probably get your hands into. Okay, so take this as a task and do it. So is that all, Jesselton? Do we have any more announcements to make? I think I'm done for the day.
Yeah, cool. Yep. Thank you, Fabian. And the feedback forms are posted on the coders chat, so do fill that. And if you have any doubts, you guys, if you have any doubts, join down. The DMC people will be waiting down to clear.
Yeah, tomorrow we'll be looking at routers again. So I think it'll be more clearer when we come back tomorrow. Okay.
Will the tomorrow session also be for 2 hours? Because
no, it'll be 1 hour.
Okay.
We'll quickly set up things and we'll get you started on what your task will essentially be, and after that it's totally you're on your own. You can do it whenever you find time, and that'll be it. And throughout this workshop we will be available at even after the workshop we will be available in the channels during the office hours. So feel free to understand, even if you left out a lot of concepts now, even if you missed out in these workshops, all these concepts will be there, and we will be there to help you out. Okay, so please fill in the feedback form and let's meet again tomorrow. So thank you for coming.
Thank you.
Yep.
Thank you, guys. Thank you, Fabi.
Thank you. Thank you, Ra.